Right, our final section, video 4. Who knew we'd be doing 4 videos? It's a lot to watch in one night, this, and really apologise, right? But it'll be worth it, I hope, right? Last stretch here, okay? So this is parallel and perpendicular lines. We revised it, okay? To be parallel, the lines need to have the same gradient. The gradient of this line isn't 2, even though it's a 2 before the x. I have to divide it by 3. The gradient of this line is 2 over 3. Okay, the y-intercept is 6 divided by 3, which is 2. Don't need that here. To be parallel, I'm looking for another one with the same gradient. Okay, weirdly though, they haven't actually written it as 2 over 3. They've right. However, if you look here, this would divide by 3, this would divide by minus 3, this would divide by 2, this would divide by 2, this would divide by 3. So the gradient of the end one is minus 3 over 2. That's 2 over minus 3, minus 2 over 3, 3 over 2, and this is the only one that's the same, 2 over 3, because like I see we've got the same setup, 3y equals 2x, 3y equals 2x. So these two, this is the one that has the same gradient as the first one, okay? So to be parallel, the gradients have to be the same. To be perpendicular, then the gradients have to be flip the sign, flip or reciprocal the number. So the gradient of our line here is 5. So if I want something perpendicular, I'm looking for something with a gradient of the plus becomes a minus, and the reciprocal of 5 is 1 over 5. So I'm looking for this gradient with x. However, we don't normally write minus 1x over 5. Right? It might be more common to see minus x over 5, but that's what that means. So it's this one, right? It's just they haven't written the 1 in there to see the minus 1 over 5. That's the one perpendicular to that. The transformation I'm pretty confident on is a negative enlargement. Okay, don't write rotation, even though it looks like it's rotated. Right, people still write in rotation. This isn't a rotation; it's an enlargement. Okay, B is half the size of A. Right, so the scale factor is a half, but it's going to be minus a half. So 1 mark for writing enlargement, 1 right mark for saying minus a half, or if B was twice as big, minus 2, right? And then to find the centre, I've only connected 2 points here because I've connected this to this and this to this. I could have also connected this down here to this, and they would have gone through the same point. I haven't got a ruler, but it would have if you used a ruler. All of them are going through here, so that's our centre of enlargement, which is 7, 4. I hated this one, so this is why I picked this one. Just in case you have to draw one, right? A scale factor of minus 3 is 3 times as far in the other direction, but they've put the centre bang in the middle of the shape here. So to get to this point, it's 2 right and 2 up. 3 times as far in the other direction would be 6 left and 6 down, so it goes here. To get to this point, it's 4 squares down. 3 times as far in the other direction is 12 squares up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I think it's there, right? And then the final point is here, which is 2 left and 4 up. The opposite of 2 left is right, but 3 times as far. Instead of 2 left would be 6, right? 1, 2, 3, 4, 5, 6. And instead of 4 up, 3 times as far would be 12 down. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, which is there. Then we can connect the points together. That one to that one to that one and back to that one. So every point is 3 times as far in the other direction. Guys, I'm only putting this in, right? Because in paper 1 you can get these wrong, in paper 2 you can't. You're literally sticking that number in instead of there, but this, and then to get that answer, and then sticking 2 in. But you can't even get minuses and things wrong because you've got calculators. So just like you would do in a trial and improvement or something, stick them in like that and work out the 2 answers. Then draw the graph, plot it. So when x is minus 5, y is 4. When x is minus 4, y is 1. So you should get a nice U-shaped curve if you get one of these, okay? Might get a part C. Draw the line y equals 2, right? And you'll see that that line cuts through your curve twice, and we want to know what the x values are for those. So what's that x value there, and what's that x value there, okay? Again, I'm now just clutching at things that could happen, right? Pythagoras, it's higher tier this, in 3 dimensions, so inside a cuboid maybe, right? Inside a shape like this, there are lots of right angle triangles, okay? It wants the length of AG. If you follow, A goes from the top corner here to the bottom corner over here. If you make a triangle here, though, you'd come down through the shape, back along the bottom here to E, and then back up to A. And it wants us to work out how long AG is, right? Well, that is a right angle. It's hidden in there, but so it's Pythag. That side is 5, but at the moment I actually don't know how far it is from E to G, okay? But if you spot, if we make this triangle E over to H, which is 7, H up to G, which is 3, and then back to E, so EHG, there is a right angle there on the floor, on the base of this cuboid, right? So to find how big this side is, which is the hypotenuse of that, right, of that, it's square, add, square root. Right, no, we don't normally write it like that. We normally kind of do them separately. Square, add, square root. 49 add 9 is 58, so it's the square root of 58. Right, could work that out. All right. Put the number there instead, whatever it is, 7.8, blah, blah, blah. Don't round it, it's not your final answer. So give quite a few decimal places. And then to get x, we're now using the second triangle with square, whatever the square root of 58 is, I guess. Squared, having said that, the square root of 58 squared is 58. So you should find, don't matter, just go on with it. And again, add and square root. So we're working out that one from square, add, square root, and then that one from square, add, square root. If you don't like my workings there, just do your own thing, okay? Okay. We had conditional probability in paper 1, but they sometimes do it twice, okay? 3 cards chosen, the one in paper 1 was, the part A was alright, but the gross one with N yellows and stuff like that. So, because we're talking about the letter C here, everything else is not C, okay? So, find the probability that the 3 cards drawn are C, so a C followed by a C followed by a C. So, initially there are 3 C's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we take a C, there is now 2 C's left out of 11. And if we take another C, there is now 1 C left out of 10. And we need to times that. That's the only combination we want here is C, C, C. Okay? You got your calculator this time, so there's just no excuses for getting any of that wrong. Don't even know what that is. 320, I don't know. Right? Use your calculators. Okay. The letters A, E, O are vowels. All the others are consonants or not vowels. Okay? Yeah. So it's vowels and not vowels, or vowels and consonants if you'd rather call them here. So right. So if we've got a lot of combinations here, we might have to think about doing the opposite, working out everything else. So calculate the probability that the 3 cards include at least 1 consonant and at least 1 vowel. Okay, so basically you have 3 cards and they have to have a vowel and a consonant. So it could be consonant, vowel, consonant, consonant, and you can see there's lots, right? But the only combinations that don't contain at least one of each is consonant, which I've already worked out in part A, and vowel, which I can work out here, 9 out of 12. Take a vowel, it goes down to 8 out of 11. Take another vowel, it goes down to that. Right? 9, 8, I'm going to actually do this. 9 times 8 times 7. This is 504, as long as I'm doing my maths right here, over 1, 320. So if I add these, I get 510 out of 1, 320. that is the probability of having either all consonants or all vowels. Any other combination will contain at least one consonant and at least one vowel. So basically I need to do 1 minus that, so everything else. Right, so what's 510 away from there? Is it 810 over 1320? So basically take the top away from the bottom because I'm looking for everything else. Rather than me doing lots of combinations here, I've kind of done the opposite. Okay. Estimated mean and relative frequency. So here's a couple of new things, but I am going to do these tomorrow, so hopefully you don't need this section of the video and you can turn off here, okay? What relative frequency is it's experimental probability. So getting your using an experiment to work out the probability. The more times you do the experiment, the more accurate the probability becomes. So for example, okay, if I threw a dice 20 times and 11 times it was heads, if I put into my calculator 11 over 20 and press equals and then like change it to a decimal, I get 0.55. So the probability of getting a heads appears to be that. But if I do it another 20 times, and so now I've done it 40 times, but I've got 18 heads, 18 over 40 is that. So using your calculators, you can work out this by doing 24 over 60 and changing it into a decimal using your FD button, right? But it's just 0.4, okay. Or, right, what out of 100 makes 0.37, so it's 37 out of 100. So you just fill it in the gaps. It may do a part B and say, what is the most accurate prediction of the probability and why? Well, like it's a bit more of a science question. The more you do the experiment, the more accurate you're getting. So my best prediction here is 0.37, and the reason is more trials. We've done it more times, so we're getting more accurate the more times we do it. But basically, you're working it out as a fraction and changing it to a decimal. So relative frequency is pretty easy. It's about doing experiments, okay? Estimated mean could very well happen. Okay, in this question here, right, it's a slightly unusual setup. You've got 3 groups, 0 to 9. Halfway between 0 and 9 is 5.5. Halfway between 10 and 19 is 14.5, and halfway between 20 and 29 is 24.5. If you only had this information to work out your to estimate your mean, right, you would do 3 times the midpoint of that, 5 times the midpoint of that, and 2 times the midpoint of that. You then add up all of your answers and divide that by the total frequency. So even though you're adding up 3 numbers, you're not dividing by 3, you're dividing by 10 because there were 10 numbers, not 3 numbers, okay? That's an estimate. This question actually got you to work out the estimate, but actually then it gave you what the numbers were actually and asked you to work it out properly by adding them all up, and dividing that by 10, okay? And it says calculate the difference between the 2 values. That is accurate because you're using the actual numbers, whereas this is an estimate because you've put the numbers into groups and you're just using the midpoint of the groups. Like you're saying, oh, well, 3 of these numbers are around 4.5, which is in the middle. 5 of them are around 14.5, okay? So a more standard looking question is this. Estimate the mean. So it's the midpoint. Halfway between 0 and 5 is 2.5 times 8. The midpoint of the next group times 0. This is going to be 0. The midpoint of the next group times 7. The midpoint of the next group times 5. Add up all your answers, but don't divide by 4. Divide by the total frequency, which is 20, and that is an estimate for you. I mean, we are so close. We mentioned this for paper 1. Exterior angles add up to 360. Interior angles, don't know what they add up to, but they are on a straight line. So your interior and your exterior will make 180. Okay, so for an octagon, the exterior would be 360. It's got to be regular, which basically means all the angles are the same. So the exterior would be 360 divided by 8. Get my calculator. 360 divided by 8, which is 45. And then the interior would be 180. Take away the 45 because they're on a straight line. The interior and exterior are on a straight line. Okay, which is 135. Okay. Or the flip of that is, instead of giving you the number of sides the shape, it might actually give you the exterior and ask how many sides the shape has. So a regular shape has an interior angle of 168 degrees. How many sides does the shape have? The interior won't help me. Don't know what the interiors add up to. So as soon as I see interior, I'm like, oh, actually, let me just take that away from 180 and actually work at the exterior. So the exterior angle of this shape must be 12 degrees, right? Exteriors add up to 360, and each one of ours is 12. So here I'm dividing 360 by the exterior angle, which will tell me that there are 30, if you use a calculator, 30 sides to this shape. So 360 divided by the number of sides will give me the exterior angle, or 360 divided by the exterior angle will give me the number of sides. Right, so that's exterior and interior angles, and that's it. We're done. Hurrah! If you've made it this far and watched all these videos, well done. All the best and good luck. And yeah, it's 2 o'clock in the morning, so I need to go to bed. See you later.